tonight what I want to take you through is two topics really. The first is factor analysis, and it's a broad introduction to the area of multivariate analysis, and it's kind of an introduction to it. And again, the whole principle of it is not to teach you about it or teach you how to do it, but just to show you what it can do and to expose you then to whether it's something that you might want to use in your research. And I'm going to follow that immediately with a cluster analysis, and that's another multivariate technique. And I'll do that by showing you, running through a research report that was done here some years ago by one of our students, Beauty Mazibuko. And then in the second half of the session, I'm going to talk to you about fuzzy cognitive mapping, which is a semi-quantitative technique. Again, the principle being that it's something that you might want to use, and just to reflect on to what extent it is that you might that might be applicable to your research. So the first thing is then exploratory factor analysis. Now, factor analysis has two kind of broad areas. The one I'm going to talk you through, exploratory factor analysis, was first published in the early 1900s, about 1903 if I'm not mistaken, but really only became popular and widely used with the accessibility of computer software that could do the mathematics of it. So there's a lot of mathematics behind both of, all of these techniques, but fortunately we've got the software to do it, so it's just a click of a few buttons and you get the results come out. So what I want to get through to you is the basic principles, and then so you can decide if it's applicable to you. Confirmatory factor analysis is a more modern technique, and is probably the more popular. I think it is the more popular one that's been in the journals, more recent journals. But it is quite different. So I want to just contrast the two so that you understand what the difference is, and so that if you do read journal articles that are using factor analysis, that you are able to understand whether it is exploratory or whether it's confirmatory. So exploratory factor analysis is when you've got a data set and you're looking in the data to see what the model might be, what the relationships might be. So it's a model building technique. So it's exploratory model building. Whereas confirmatory factor analysis is a technique where you start off with your model and then you see whether your data fits the model that you've got. So it's confirmatory because it either confirms or doesn't the model that you're working with. So exploratory creates the model, confirmatory can test the model. And that's the fundamental difference. Okay. But the principles are the same, and the sort of basic understanding is the same. So the starting point really is the fact that when you've got a data set, every variable in your data set is essentially a dimension of data. So what I mean by that is that if you've got a data set of different people within your organization and you've got two variables, let's say age and income, you could plot that on a two-dimensional chart where you have age along the horizontal axis and income along the vertical axis, and you could see the relationships between the two. So two variables, two dimensions. If you've got a survey where you've asked, let's say, 20 questions, you've then got 20-dimensional data. Now, it's quite easy to represent data in two dimensions. We can do it on a piece of paper or on a screen, but it's not going to be possible to represent 20 dimensions of data. 3 dimensions of data we can kind of conceptualize, right? Because we live in 3 dimensions. 4 dimensions and more starts to become very difficult. So the complexity of the data is something that is a challenge for us when we're analyzing data for research project purposes. So the technique of factor analysis, or related to that is what we call principal component analysis, is to assist with reducing the complexity of the data so that we don't have as much data or as many variables to understand and to get our mind around. So the other thing that we're doing with factor analysis is to understand the underlying structure of the data, and I'll show you what we mean by that just now. So what I'm showing you in this case is I'm just trying to show you the basics of how factor analysis works. I've got two variables, x1 and x2, and I'm suggesting then that each of those data points is one of the observations on in our database. And I think you can see that that there's kind of a correlation between the two. Each data point is a certain distance along my horizontal x1 axis, a certain distance up the vertical x2 axis. And that's very conventional. That's how we would how we represent scatter charts. I mean, Excel can do it, and I'm sure you've seen that before. So every data point representing an observation in the data set, 2 variables. Now what I can do is I can redraw those axes. Without changing the actual data itself, I can redraw those axes like that. So instead of defining each data point as a certain distance along the x-axis, x1 axis, and a certain distance along the x2 axis, what I've done there is I've defined each data point as a certain distance along my f1 factor and a certain distance along the f2 factor. And the f1 factor has been constructed in such a way as the maximum variability of the data occurs along that axis. So I'm trying to capture as much information along that first f1 factor 1 axis as possible. Whatever's left comes out in the second factor, the factor 2. So the principle of factor analysis is that if we want to optimize the relationship between the complexity of the data and the amount of data that we retain, I can discard some of the data and still retain the essence of it. So if I then discard factor 2, all right, so I say let's just have one factor here, and let's then collapse all of those data points down onto the single factor. I now have got one-dimensional data, and that one dimension captures the majority of the information. And anything that we've lost, all right, so we've lost a certain amount of information about the data, but what we've done is that we've retained the maximum and halved the complexity by halving the number of variables. Right. So that's essentially what I'm saying, is that we can discard some. There's a trade-off between discarding some information and the complexity, the number of variables that we have. So it's a data reduction technique, reducing the number of variables and discarding information that is hopefully not particularly useful. Now you might say, well, isn't that just a mathematical sort of a mathematical technique? Well, there is a principle underlying that. And the model that we use to show that then is this. And what I'm showing you there, we've got 2 types of variables. We've got manifest variables, which are the observations or the measurements, the actual data that we've got. And we've got variables here that are referred to as latent variables. They're latent in that they are unobserved, so we don't actually know what they are. But the principle is that if we've got two variables, such as the x1 and x2 that I showed you in the previous case, that are related to one another, they're correlated to one another, then it may well be that there's an underlying variable that is actually driving both of those. If there's an underlying variable here that is driving both of those, then that manifest variable will be correlated with the latent variable, and so will that one be correlated. Therefore, they will be correlated with each other. So if I ask 2 questions in a survey about some underlying construct, such as job satisfaction, all right, the questions I ask about job satisfaction are likely to have some degree of correlation between them. And the questions that will then allude to some underlying construct being this job satisfaction, or how the person thinks about and perceives their job satisfaction. So if you think about what I spoke to you about a couple of sessions back, where I was saying that we want to get inside our respondents' and participants' heads and their thoughts and feelings. And when they answer surveys or answer your questions in an interview, there's a filtering process going on. That information there is filtered. But maybe by getting behind it, getting to this latent variable, we're actually getting inside the underlying motivator or the underlying driver. So that is what we're doing here. Now with confirmatory factor analysis, what we have, we start off with this model. So we start off with a model that says that we've got certain variables that we're going to measure in a survey, and that they are related in some way through some sort of latent variable. That's confirmatory factor analysis, where we start with the model. With exploratory factor analysis, we start only with the manifest variables, and we effectively reverse engineer. We pull it apart in such a way as we find out what these latent variables are. So that's the difference, in approaching the problem from opposite directions. So those ones we don't know about, and those ones we do know about. And what we're going to see when we actually do the analysis is that the strength of these relationships actually helps us to interpret what this latent variable is. We know what these are, we don't always know what those are. So what I'm going to do now is I'm going to show you a couple of examples, just so you get a sense of it before we go into the example of the research report. So what I'm showing you there, can you read it at the back there? Okay. What I'm showing you there are a series of questions that were asked in an IT organization as part of a 360-degree performance appraisal process, and they all came under the broad heading of communication. Right? So each person was given a rating on these 10 items. Okay. Now, if you look at those items, it's not clear whether they are all simply related to communication or whether there's some underlying structure. In other words, there's competencies that are in the communication area but are actually different from one another. So in other words, that if there are underlying factors or dimensions of communication, it's not obvious just by looking at those. When running the factor analysis, however, it turned out that there were 2 factors. So the maths told us that those 5 items were correlated with one another, and those top 5 were correlated with one another. So the inference then is that there's something underlying, some underlying competence that is described by these 5 manifest variables, and that there's another underlying competence of communications which underpins the top 5. So what I want you to do is I want you to look at those items, the wording of the items, because it's only in the wording that we know what those, what's the sort of common theme that comes out through those. Because the wording of these items tells us what that latent variable is. So can you see the similarity between the top 5, the similarities between the bottom 5, in such a way that they are different from one another? Because when I spoke to you about validity, you might remember I talked about convergent validity and discriminant validity. Convergent validity means that whatever we label this, it has to correspond with these. And whatever we label this has to be different from and differentiated from whatever we label the top 5, because they have to be different from one another, to be distinct from one another. In other words, that's where the discriminant validity comes from, so that we can discriminate between the factors. One of the problems with factor analysis, exploratory factor analysis, is that if you do the analysis and I do the analysis, we might come up with different descriptors and different words for it. And so certainly that is a criticism, because in terms of traditional quantitative methods is that 2 people analyzing the same data set are going to come up with the same answers. All right. So the way they were labeled when we did this exercise was engagement are the first items. All right, can you see the connection there? They're engagement dimensions. And then the second one was pragmatic and practical. In other words, more to do with the exchange of technical information. All right. Now, I'm not saying that's right. I'm just saying that's what the organization came up with in the context of their IT work that they did. So what that's saying now is that everybody has a score on every one of those 10 variables. But now we can actually position them in 2 dimensions. So we can actually then plot it on a 2-dimensional axis, where every person will be somewhere in that 2-dimensional space instead of being in 10-dimensional space. So we can now conceptualize it. And the interesting thing is that if you think about it from a practical point of view, you get people in all 4 of these quadrants. So you're going to get some people that are good at both engagement and at the practical. You're going to get some people that are potentially weak at both the engagement and the practical. But if you get some people here, as you would do, in low engagement score and high practical to technical communication, those are your propeller heads, right? The ones that can't actually engage with people too well. It's a very different type of person from a person that's sitting up in this corner where they're good on the engagement and poor on the communication of technical skills. And the sort of intervention, the sort of management intervention that they would need and training in those competencies would be hugely different. So what this has done for us is, in this environment, it's separated out different aspects of communication to enable us to get the underlying competencies rather than the manifest competencies, which is all of the variables that we've actually measured. So it's much more targeted, much more straightforward. And we've done that in such a way as we've kept the fundamentals and we've discarded the spurious, the detail. We've kind of done a trade-off there. Does that make sense? So that's what this whole technique is doing. Another example from the same context, looking at the technical competencies now, is that set there. And when we did the analysis, in this case it came out to be 3 factors. So those were the 3 factors. So you've got the 5 at the top, then the next 5, and then the following 5. So again, if you just have a look and see, based on it's based on the wording of the manifest variables. So based on the semantics of each of these items here, what do you think? What would you label those? Bearing in mind it's a technical, it's all technical, and it's an IT environment. Any thoughts on what those might be? Development, analysis. You said analysis? You said analysis, right? Okay, that's good. What about the last one? This one here. Yeah, you're absolutely right. Look at, I think 4 out of the 5 have training in the actual words, in the actual descriptors. So clearly that's the common theme, isn't it? What about the middle one? Configuration. You notice that the word configuration appears in every one of them. All right, so the labels that came out for that one, and you used the word analysis, absolutely, you were spot on there, configuration and training. So what that's saying is that in this organization, there are 3 dimensions of technical competence, and not actually the 15 dimensions that they started off with. Again, much easier to understand in terms of kind of the whole performance management process, understanding the competencies and interventions if necessary. So in that case, what you had is that you would have 3 dimensions. I've tried to show the 3rd dimension sort of going in and out of the board there. Okay.
Do you plug anything inside the graphs, or do you just leave them like that?
I'll show you just now. I'll show you in the example how we might do it. Yeah. All right. All right. So the process of doing a factor analysis is that you would collect your data, and typically it's a sort of survey data, but it doesn't have to be done on a survey. But it is a quantitative technique, so it's not, we wouldn't do this on a small sample qualitative technique. Then one runs the factor analysis, and there are 2 aspects of that, and this is just really just a case of running the software. You decide on how many dimensions there are in the data, and I'll show you one of the tools that we use to determine that. And then we do something called rotating of the factors, and that's just to assist us with the interpretation of what the factors mean. But then you actually do the interpretation of the underlying factors, and then the last aspect of that is you then do the interpretation of what we call the factor scores. Now what I mean there is that if we go back to this chart here, it might be that different types of people or different demographics fall into different areas, and that might be really interesting. We might find that engineers and technicians actually have different competencies. It might be that males and females have different communication skills. So we might want to interrogate that data sort of a step further or somewhat deeper. So we can go into this further. So factor analysis doesn't just stop at the factor analysis, right? Although that might be part of what we're interested in, we can take it a step further. And that's what I'm going to show you with the with the data set from beauty. Yeah.
Just back on that, how did you elect which way to plot the green line?
How did I relate?
How did you elect which way to plot the green line? Could it have been on the
Okay,
other
interestingly, it doesn't matter which way we plot it, because although the numbers come out as positive and negative, all right, it's not about good or bad. There's no value judgments. It's just two ends of a spectrum. All right, and we'll see that when we do the Beauty Mazabuka. So I just tried to create the impression there. So, but it actually, the direction doesn't matter, in fact. Okay, it's just a separation. Okay, yeah.
So if you may go one slide back again. So, in this scenario, everything is boxing into one box, if I could call it that. So what if one of those line items are correlated to two of the three? How do you box it then? Can you still use this?
Yes, you can. We talk about that as cross-loading. All right. So there's not a problem if that happens. But when we talk about a validated survey, usually what's happened is that they've gone through and eliminated those cross-loading, so they get a clean factor structure, as it's referred to. So typically you will get some cross-loading. All right. In fact, you'll always get some. But just because of the mathematics of it. But the question is to how much. Yes, sometimes you do get quite a lot of cross-loading. So it's not a problem. Yeah.
Next slide, that green line. Am I right in assuming that if somebody obtains high configuration score in combination with high analysis and modeling score, they need low training score, or they get low training score in terms of putting in points? It's not that.
Anybody can be anywhere in those dimensions. They are independent of one another. So somebody could be high on all of them, could be high on two of them, low on one of them. They could be low on all of them. They can fit anywhere within that space. All right. So no, it doesn't mean that they are. In fact, explicitly means they're not dependent on one another. Okay. What I'm going to do now is I'm going to go into this example here. And the title of Beauty Mazabuka's research was the dominant strategies used within the South African retail industry. And she was looking specifically at the retail clothing industry, clothing retailers. So her research problem, what she was interested to know was, do clothing retailers adopt classic strategies that we learn about in strategy at business school? Right? That was what she was wanting to know. So whether they are unique, or whether they're unique competitive strategies to the clothing industry. And then she also wanted to know whether size had something to do with it. All right, so the strategies that were followed. And the way she did it is she collected data through a self-report. In other words, she went to the clothing stores and asked the owners and managers how they perceived themselves to be competitive. So, right? So it wasn't about how the market perceived them. It wasn't about how the consumers perceived them. It was about how the actual owners or managers themselves said that they competed and were competitive in that retail environment. So it's potentially fundamentally different to the way the market looks at them. And in fact, we'll see what looks like anomalies in the final results. But that's probably because they weren't actually following any of the real strategies that the market saw, from the outside. So what she did is she compiled this survey where she went to the clothing stores. It was a paper-based survey, and asked them to what extent do they agree or disagree with this list of statements. Now, if you go through that list of statements, you'll see that they all come essentially from the strategy literature in one form or another. So I think we spoke last time about where do you get your questions from, right? You get it from your literature. And I think I also spoke to you about the fact that you need to make sure, I think it was under face validity, you need to make sure that your questions cover the entire scope of what you're interested in. And that's what she tried to do. So she tried to capture all of those items there as having something to do with strategy, but she didn't predetermine what the dimensions were. So she didn't have a model. So she wasn't saying in advance that these are the strategies out of the strategy literature and try and fit a model to it. She was saying, what are the strategies? Being open to the possibility of anything essentially coming out. So she did the survey, she did the response format was on a scale from basically from strongly disagree to strongly agree. She captured that and coded that as sort of 1 to 7, a 7-point Likert scale. And that's what the data set looks like in SAS. So over here you've got the brand, the actual clothing retail itself, and then here are all the questions, or sorry, not questions, the statements that people either agreed with or disagreed with on that scale. Now I'm not going to go through the analysis itself, purely because of time, and I don't think it's necessary to get the learning experience I'm looking for. What you see there is what's called the scree plot, and the name comes from the geological definition of scree, and what you see is some high eigenvalues here and then a whole lot of lower ones over here. Now the mathematics of this technique of factor analysis result in these eigenvalues which tell us how much of the information is within each of the factors. Right, so what you're seeing here is factor 1 contains the most information. Factor 2 contains not as much as factor 1, but still quite a lot more than the rest, and so on. So as you get more and more factors, all right, you capture more and more information, but obviously you add to the complexity of it. So there's a trade-off now between the number of factors and the amount of information. So we've got to decide at what point we're going to choose to have a certain number of factors. The dotted line that I'm showing here is a line that we've determined statistically that is the line of the eigenvalues if we had completely random data. In other words, if there was no patterns in the data, no correlations within that data set, what we would find is that our eigenvalues fell along this line, not as I'm showing here the scree plot. The logic being that if my eigenvalue for a particular factor falls above that line, it means that there's more information than randomness. If the eigenvalue falls below that line, it means that we've probably got just random data. So in this case, that line tells us we need to have 3 factors in this data, or we've got 3 factors in this data. And so that's the decision about it. In this case, it's very clear that it's 3. Other cases, we sometimes find data sets where it's not quite as obvious as this. So we've got a 3-factor solution, as we would refer to it. So the question then becomes, well, what are those 3 factors? So it's going to be 3 dimensions of data. Again, I'm trying to show it in such a way that the third factor is sort of coming out from the board and going in on the negative side. And what the software will tell us is what we call the factor loadings. And that's what I'm showing there. So the way I've grouped it is the first 6 items at the top there all relate to factor 1. The next 5 relate to factor 2, and the next 5 relate to factor 3. So what we're going to do now is we're going to go in and we're going to put those onto those axes, and then we need to interpret the axes. Right, so those scores there, or factor loadings, are essentially the weighting of those arrows I showed you in the earlier presentation. It's essentially a correlation coefficient. Okay. You'll see that some of them are positive, some of them are negative. All right, and what that means is that those items are at opposite ends of the axis. So what it turns out then is that we have those 3 axes, and we can now say, and if we just look at the blue axis to start with, on the positive side we have these 5 items here, and on the negative side we focus on pricing below competitors. So what we now need to do is we need to go through those 5 and the one on the other side and ask ourselves the question, where in the strategy literature, in theory of strategy, do we find a separation that can be captured with these manifest variables? You understand? These are the manifest variables. These are the ones we've actually measured. But what we're trying to find are what are the latent variables, the underlying variables, right? Which I'm saying the fundamentals that maybe come from the strategy theory. So over here we put specific effort to ensure a pool of highly trained, experienced personnel. We focus on improving our operating efficiency. We ensure added service which appeals to certain segments. We put concerted effort to build reputation within the industry, and we continually innovate our marketing techniques and methods. So that's the one kind of description of a strategic choice, and on the other side we focus on pricing below competitors. What does that sound like to you based on what you learnt in strategy?
Low cost strategy.
Okay, so low cost presumably on that side. What's this side? If you're not following low cost, what did Michael Porter say about?
Niche.
Thank you. All right. Differentiation. So all of these appear to be using some form of differentiation strategy. That one appears to be a low cost strategy. So what we see here in the context of retailers, the first factor or the first dimension is the classic Michael Porter dimension of strategy, the differentiation versus low cost. Okay. So going back to the research question is, are there unique strategies used in the clothing retail industry? Well, certainly that first dimension is not unique, because that was what Porter said, is it's a generic strategy. Let's leave the second dimension for now. What about the green dimension here? On the one side, we supply products to lower priced market segments. We compete on the basis of a broad product range to maintain market share based on price, and we maintain high inventory levels. Versus at the other side, we only serve specific geographic markets. We supply products in higher priced market segments. Again, in the context of strategy, because this is what we're talking here, right? These are all strategy dimensions. Where does that, what resonates for you there?
One is the top right, is that not maybe not niche markets, and the other one is not mass production.
Okay. I would go along with that. Can you see that? So what we're saying down here, this end of factor 3 is really characterizes mass markets, whereas the top side, the other opposite end of that dimension really looks more at niche. And again, I would argue that that's fairly classic market positioning strategy. So again, we see that there's nothing unique about that. But certainly it seems to fit with the strategy literature. And the point is that's independent of the differentiation low-cost strategy. Okay, so it's a separate dimension. Now, what about the vertical axis? We haven't got anything at the bottom here. We've only got some 5 manifest variables on the positive side of the vertical of that factor, the vertical axis. Putting effort to ensure that our core competencies are difficult for competitors to imitate, compete based on scales of economies and so on. What do you think those characterize? Not quite as easy maybe to pick up. You've got to be careful about, you use brand differentiation. Again, you need to make sure that you've got the discriminant validity. So we've already used the word discriminate to differentiate. All right? So discriminating is very similar to differentiating. So we need to make sure our labeling is distinct from the other axes. Okay. Let me put it to you this way. In what part of your MBA program would you deal with these issues?
Operation.
Right. Absolutely. Can you see that those are largely operational issues? So I kind of label that one, and I'm more familiar obviously with the data set than you are. I label those as sort of operations and logistics. So anybody saying that they use those as their means of competing are really using their operations and their logistics to be competitive. So on the negative side here, we don't have anything here. So all that means is that anybody that is not using operations and logistics as a competitive tool, they're going to be on the negative side of this axis. They're going to fall on the low end of axis 2 or factor 2. So just for the sake of labeling it, I actually label that as the sort of the outsourced logistics, because if it's not competitive, maybe you outsource it. And I'm not saying that one necessarily does, but just to give it a label and a descriptor, I refer to that as outsourced logistics. So we now have these 3 dimensions where we've got the low cost differentiation, the Porter strategy, we've got the supply chain and operations management, the logistics versus outsourced logistics, and the mass market versus niche. And again, I say, notice that it's not good or bad. It's not that there is, that any one direction is better than another. It's simply indicating the differences of strategy. So each and every clothing retailer is now going to be positioned somewhere in this 3-dimensional space, depending on how they have reported their competitive strategy. So what we see there now are these factor scores, and so we can see literally on these 3 dimensions where each of those clothing retailers is positioned. What we're now going to do is we're now going to follow this up. So that's the factor analysis. We're now going to follow this up with a cluster analysis. Now, what we do with a cluster analysis is as follows. Factor analysis kind of grouped our variables, okay, into groups where their variables are similar. What we're going to do with cluster analysis is we're going to take our retailers and we're going to group them. So it's very much like a market segmentation. In this case, what we're doing is we're going to look at which retailers fall into which clusters, and essentially they are then competing against the people using the same strategies. Okay, so anybody in a particular cluster is going to be competing with other retailers in their same cluster, whereas other retailers in another cluster are using a fundamentally different strategy, or combination of strategies. So that's what cluster analysis is going to do for us. It's going to group in this case, the retail stores, the observations in our database. It's going to group those according to the similarity of their combined strategies. In other words, the 3 dimensions of strategy.
And Anthony, I noticed that you only asked one question, and all those are like it was just agree or disagree on one question.
No, it was a scale from strongly disagree,
it's a
disagree,
scale.
moderately disagree. Yeah, so it was a 7-point scale.
Okay, so several questions and they need to answer.
Well, they had 16 questions, and they gave a rating for each one. Okay, so they had a score on each of the questions, right? And that's what you can see. So each of these is a retailer, and then here are their scores for that particular question, and that's the scores for that particular question.
Right.
Okay, so we had a score for each of those statements about strategy.
Okay, so
for
this
each of the
only
clothing
works on a Likert type scale when
Well,
you're analyzing that data.
Typically, that's how we're going to use it, but it can work on other numeric data as well. Yeah, we can do it in other data. So you can. It might be performance statistics of projects or something like that. You might have dimensions of that. There's various ways you could do it. But the sort of work that we do here at the business school, mostly it's survey data. Yeah. All right. So what we're doing, we're going to be using these numbers here, the factor scores, and seeing whether there are groups that cluster together. Okay. So it's exactly what one would do in a marketing context if you're trying to segment your market. You're going to try and see if you've got clients or customers with similar needs or similar perceptions. Okay, so it's exactly the same as a segmentation exercise. Cluster analysis is essentially a segmentation exercise or segmentation tool. So again, I'm not going to go through the detail of it, but just to show that what we get from that is we get a cluster number. So what we get is a label that we can label them ourselves, but basically we separate each of them into a specific cluster, and they are grouped around the average for that cluster. This column here just tells us how far away they are from the center of the cluster. Again, we have a scree plot which tells us how many clusters we've got. In this case, we're going to have our cutoff point over here, where we have 4 clusters. Right? So what this is telling us is that we have 4 groups of clothing retailers that have essentially similar combined strategies. And how do we know what those are? Well, we'll look then at the averages for those clusters. So what we're seeing in this table here, I'm not going to look so much at the bottom part of the table, but if we look at the top part of the table, we see that those retailers in cluster 1, they have an average on factor 1 of -1. So if we think about where those were, -1, the negative side of factor 1 was the low cost strategy. So what we see is that those retailers in cluster 1 have typically been following a low cost strategy. If we look at cluster 2, we see that they are moderately high on factor 1, quite close to 0 on factor 2, and quite negative on factor 3. So that means strongly negative on factor 3 means niche market. That's how we define negative on factor 3. Niche market, differentiated. So it's a combination of the niche and differentiated is the strategy of those retailers in cluster 2. If we look at cluster 3, what we see is that they are high on factor 1 and low on factor 2, high on factor 3. So what that's saying is that they are differentiating themselves. They're not using logistics and operations to compete, and they are claiming to be on the positive side, so mass market. All right, now that's an interesting one. All right, what that means is that they say that they're looking at the mass market. They say they're different from their competitors. They're differentiating themselves. They also might be delusional. All right, that might not be an effective strategy. If one looks at then cluster 4, they're high on factor 2, so they're using logistics, all right, as a part of their competitive strategy, and they're relatively high on factor 3, so they're mass market and using logistics, and that makes some sense. So just something's a little bit confusing about cluster 3, that they might be a little bit confused about their strategy. So what I'm showing you now in this particular slide is just looking at factor 2 and factor 1 and factor 2. You can see how the clustering has worked. So cluster 1, you can see all of those diamonds, the blue diamonds, are in that area. We said that they all have the negative score on factor 1. They were all on the low cost side of factor 1, and so on. That's the easiest one to see. We can't see the third dimension in this view, but you can see that they are clustered. And if I set that going and sort of rotate the axes around, you can see in the different perspectives, you can see how they are clustered around similar strategies, similar combinations of strategies. Because each clothing store actually has a combination of strategies in those 3 dimensions. So we can see then that they have grouped into those logical clusters. It's not going to be easy to present that in your final report. Yeah, one of the full-time class suggested a 3D printer was necessary. So yes. I was saying this in the class this morning to the full-time class that Terry Carmichael, you had Terry Carmichael earlier in the year, didn't you? Just for 1 or 2 sessions. She put together a 3-dimensional model for her PhD. So literally, I mean, she built it up out of cardboard. So anyway, what I'm trying to illustrate here is the concept of clustering in 3 dimensions. Okay, we can see how they've grouped around one another. Okay. So the last part of Beauty Mazibuka's research was to look at whether there's a relationship between size and strategy. So essentially whether there's a relationship between the size of the retailer, all right, so there's a variable which is showing us the size, there's some medium and large retailers as well, and the cluster that they're in. And the technique that we would use for that is what's called a chi-squared test. So again, I'm not going to take you through the test, just to go straight through to the results of the test. And what you see here, the way the chi-squared test works is that it works out that if size and the cluster are independent of one another, we would expect to see around about 11 large retailers in cluster 1. We'd expect around about 8 or 9 medium-sized retailers, and we'd expect around 32 small retailers. What we actually see is that we've only got 2 large, we've got no medium-sized retailers, and instead of 32, we've actually got 50 small retailers. So the point about that is that in respect of cluster 1, we can see that size and the cluster grouping are not independent. It appears as if cluster 1 is comprised of a lot of small retailers. Similarly, we see that for cluster 2, all right, which remember we interpreted cluster 2 just now, we see that there are more large and medium than there are small. There are in fact very few small retailers in cluster 2. So similarly with cluster 2, size matters. Because with cluster 3 and 4, all right, size doesn't matter. All right. So in terms of Beauty Mazibuko's question about to what extent size is related to strategy, what we see is that to an extent, yes, size is related to how their strategy, the sort of generic strategies they use, but not conclusively, not universally. So it depends kind of in the sense as to which clusters you're in. All right, so that's really where she went with her project. So what I was wanting to show with that is how we can take this relatively complex data set of 16 variables, 100 and something observations, and we can simplify it, we can break it down into 3 dimensions of strategy, which we're able to identify. We're able to then cluster it into 4 distinct clusters, sort of competitive clusters based on strategy, and that we were then able to analyze it for size as well, which is what she was wanting to do, what she set out to do. But there were 3 very distinct stages of analysis: the factor analysis, the cluster analysis, both of which then are multivariate techniques, and then a more conventional statistical technique, the chi-squared test of independence, where we were able to see the relationship, or whether there was a relationship between size and cluster. All right. So it's just to show you how one would fit that into a sequence of analyses.